when factoring doesn't work, when completing the square doesn't work, your last-ditch effort to solve a quadratic equation is using the quadratic formula. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. It says all over 2a because that division bar has to extend underneath the opposite of b and underneath the square root. I am not going to require you to memorize this formula because that's not very realistic. In the real world, if you need a formula, there's this thing called Google, and it tells you formulas if you ask it. So I'm not going to specifically require that you must memorize this formula. However, if you have it memorized, it makes it a whole lot easier to do these problems. So I would strongly suggest that you try to memorize it. And I have a handy-dandy way for you to memorize it using the tune Pop Goes the Weasel. Are you all familiar with the tune Pop Goes the Weasel? You know, when you're a kid, the little thing that you twist like Pop goes the weasel. Yeah, well, I don't know. Well, the original song is Pop Goes the Weasel. Yeah. So, I'm kind of glad that I'm sick so you guys can't critique my singing voice because, you know, I'm sick so you can't be judgy. So, here's the song to the tune Pop Goes the Weasel. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A is always your number in front of x squared, b is always your number in front of x, and c is always the number by itself. In number 1, let's go through this process. First thing I'd like you to do is write down a is 5, b is 3, c is -1. Really, with the quadratic formula, you're just putting the right numbers in the right places. That's all it is. You're given the formula, you're given the numbers, plug it all in. So x equals opposite of b. Because we have positive 3, we're going to put in -3 plus or minus big long square root. b squared, so 3 squared, minus 4 times a, 5, times c, -1. The whole thing over 2a, so 2 times 5. Okay, grab your handy-dandy calculator and do the stuff under the square root. 3 squared minus 4 times 5 times -1. Once you've simplified whatever's under the square root, you need to think about, can I simplify this square root? So can we simplify the square root of 29? 16, 9, 4, no. So this is our answer. X equals -3 plus or minus the square root of 29 over 10. On your assignments, I would allow you to leave it like that, simplified quadratic formula. But I do want you to know what this means. When we do the quadratic formula, we are really truly finding where this quadratic equation, where the parabola is going to cross the x-axis. So if we actually wanted to know the specific x values, we would do -3 plus the square root of 29. Hit enter. You want to do everything on the top and hit enter. Then divide by 10. One of our solutions is approximately 0.24. Then you do the problem again using subtraction. -3 minus the square root of 29. Enter. Divided by 10. Enter. The other solution is -0.84. And if you're still confused what these weird decimals mean, The equation was 5x squared plus 3x minus 1 equals 0. If I put that equation into the graphing calculator and ask this calculator to give me a graph of the parabola, take a look at where this graph crosses the x-axis, at approximately negative 0.8 and at approximately 0.2. So the quadratic formula, what it's really doing is it's telling you where this parabola is going to cross the x-axis. So that's something that's worth keeping in your mind. Number 2, let's start number 2. What is our a value? 6. B is negative 8. C is 3. X equals opposite of B, so this time we use positive 8 plus or minus the square root. Now, b squared, anytime your b is negative, I'm going to strongly recommend you put the negative 8 in parentheses. Minus 4 times a times c, all over 2 times a, 2 times 6. Okay, in your calculator, do the stuff that's under the radical. If you use the parentheses, like I suggested, negative 8 squared minus 4 times 6 times 3. Here's what happens if you don't put the negative 8 in parentheses. You end up getting negative 136. So why in the world did this calculator that's supposedly so smart get this wrong? The calculator is really truly doing order of operations. So when it sees negative 8 squared, it's doing the 8 squared first, and then it's sticking the negative on it. But think about it. Should something squared be negative? No, this should definitely be positive 64. So if you want your calculator to treat that negative number correctly, you have to put parentheses around the negative number. Otherwise, your calculator will do the problem incorrectly. The other way to combat this, if you know your perfect squares pretty well, if you're putting in negative 8 squared, just go ahead and do that math in your head. Write down positive 64 minus 4 times 6 times 3. That way you won't make that mistake in your calculator. All right, so we have x equals 8 plus or minus the square root of negative 8 all over 12. What do you think we're going to have to do next? Simplify the square root of negative 8. Well, there's definitely a square root of negative 1 in there. How do we break up 8 using perfect squares? Square root of 4, square root of 2. The square root of negative 1 is I. The square root of 4 is 2. So we have x equals 8 plus or minus 2i square root of 2 all over 12. This division bar means that this is 8 divided by 12 plus or minus 2i square root of 2 divided by 12. Because we're dividing by 12, you can look at those whole number pieces and cancel out a common factor. So do 8, 2, and 12. Is there some number that you can divide out of all three of those? 2. So we're going to divide everything by 2. That will make our final answer. 8 divided by 2 is 4. 2 divided by 2 is 1. So we would just have I square root of 2. And 12 divided by 2 is 6. Now, can we simplify this more? We would have to separate the two fractions and make it 4/6 plus or minus I square root of 2 over 6. and that's really not worth it. So this is as simplified as I want you to make it. Make sure that the whole number pieces in front of each three parts are as simplified as you can. Everything's negative. More importantly, in front of our x squared, we have a negative number. Now, you can do the quadratic formula with an a value that's negative, but it really makes more work for you. So I'm going to advocate for being strategically lazy whenever possible. I don't want to deal with a negative a value. So you can do a couple things. You can multiply every single term by -1. You can divide every term by -1. You can think of it as adding 4x squared to both sides, adding 9x to both sides, adding 3 to both sides. But ultimately, you want to get 0 equals positive 4x squared plus 9x plus 3. Now, our a value is positive 4. Our b value is 9, and c is 3. Take a moment and see if you can do the quadratic formula yourself using those numbers. You should get this. You can't simplify the square root of 33 anymore, so that is your final answer. All right, what's going on with number 4? It's big numbers, and it's definitely not in the right order at all. We need to get everything to one side of the equation and make sure it's written in standard form. So I'm going to add 7x squared to both sides. That will give me 4x squared. I'm going to subtract 40x on both sides. So I've got 0 on the left. And I really don't want to write 101 in the front. I really want the plus 101 to be at the end. Once you have it with everything on one side of the equation and in standard form, x squared, then x, then the number, our a is 4, b is -40, and c is 101. See if you can do the quadratic formula with those numbers. Okay, so put each of these numbers into the quadratic formula. Remember my warning, when your b value is negative, you should really put that negative b value in parentheses so that when you plug in the stuff under the square root into your calculator treats that negative number correctly. You should end up with -16 underneath your radical. So then we would take the square root of -16 and simplify that. 16 is a perfect square. So this is 4 and I. Do 44 and 8 have a common factor that we could divide out of all of them? We can divide all of them by 4. So our final answer will be 10 plus or minus I over 2. Okay, now remember that first example? I showed you the 2 points where it crosses the x-axis. What if you've got a quadratic equation where your solutions have I in them? What's that going to look like on a graph? This is going to be the kind of parabola that looks like this. Notice this parabola doesn't cross the x-axis at all. There are no real solutions where that parabola crosses the x-axis. There are only imaginary solutions. So if you ever have a parabola that doesn't cross the x-axis, if you did the quadratic formula with its equation, you would get something with i's. Looks like a lot. It's really only 5 problems. And I did give you the odd problems, so if you want to check your answer in the back of the book, you can. Copying the answers from the back of the book does not help you learn math, but checking your answers to see if you got it correct is a good strategy.